Today we'll solve a calculus problem. We have a function f of x and y, defined as g of 2 times y plus e to the x, and we know g prime of 1 is -1. We need to check three statements about the function at the point 0, 0. All three statements involve the directional derivative, so the key is the gradient vector at 0, 0. Let's find the partial derivatives, f sub x and f sub y. Using the chain rule, the partial derivative f sub x is g prime of 2 times y plus e to the x, all multiplied by e to the x. Similarly, f sub y is g prime of 2 times y plus e to the x, all multiplied by 2. Now we plug in x equals 0 and y equals 0. Since e to the 0 is 1, both derivatives depend on g prime of 1. Using the given g prime of 1 equals -1, we find f sub x at 0, 0 is -1. And f sub y at 0, 0 is 2 times -1, which is -2. So, the gradient vector is -1, -2. Now, let's check the statements. Statement 1 says the maximum directional derivative is the square root of 5. This maximum value is just the magnitude, or length, of our gradient. The magnitude of the vector -1, -2 is the square root of -1 squared plus -2 squared, which is the square root of 1 plus 4, or the square root of 5. Statement 1 is true. Statement 2 says the fastest decrease is in direction 2. The fastest decrease is in the direction opposite to the gradient. The opposite of our gradient, -1, -2, is the vector 1, 2. This vector corresponds to the line y equals 2x, which is exactly direction 2 in the diagram. Statement 2 is true. Statement 3 says the derivative is 0 in directions 4 or 8. The derivative is 0 only if the direction is perpendicular to the gradient, meaning the dot product is 0. Our gradient is -1, -2. Direction 4 is the vector -1, 2. Their dot product is -1 times -1, plus -2 times 2, which is 1 minus 4, or -3. That's not 0. Direction 8 is the vector 1, -2. Their dot product is -1 times 1, plus -2 times -2, which is -1 plus 4, or 3. That's also not 0. Since neither dot product is 0, statement 3 is false. So, we found statements 1 and 2 are true, and statement 3 is false. Thanks for listening.